Hello, AP Statistics students. Welcome to this edition of AP Free Response Tutorial. In this video, we're going to take a look at 2018 number 5. So let's take a look. The following histograms summarize the teaching year for the teachers at two high schools, A and B. All right, so we got two histograms. Teaching year is recorded as an integer, with first year teachers recorded as a 1, second year teachers recorded as a 2, and so on. Both sets of data have a mean teaching year of 8.2, with data recorded from 200 teachers at A and 221 teachers at high school B. On the histograms, each interval represents possible integer values from the left endpoint up to but not including the right endpoint. All right, not anything too crazy yet. Letter A, the median teaching year for one high school is 6, and the median teaching year for the other high school is 7. Identify which high school has each median and justify your answer. So which one has a median of 6 and which one has a median of 7? Now, one tempting idea would be to talk about the skew. I'm guessing that was the distractor they had. Would students talk about skew? Because they're both slightly skewed to the right. The high school B is definitely heavily skewed to the right. But that would leave you dead in the water. The median is not affected much by skew. It's the mean that is pulled by skew. And so the median is a resistant measure of center, if you remember. So you definitely don't want to talk about skew. This one's kind of a weird question. It's sort of a coincidence that you are allowed to answer this question because 6 and 7 are the boundaries of one of the bins. That's why you can answer this question. So for this high school, if the median is supposed to be in this bin, then you know it has to be 6 because it can't be 7. If it's in this bin, however, you know it has to be the 7 because it can't be the 6. That's how histograms work. Each bin includes the left endpoint, but not the right endpoint. And they even gave us that hint right here. They reminded us of that fact. Each interval represents and includes the left endpoint, but not the right endpoint. So again, 6 would be in this bin, and 7 would be in this bin. So where is the median? We simply have to count. So if you remember, the question says that this high school A has a total of 200 teachers. So that means the median, you're going to have 100 on each side. So the middle is going to be between the 100 and the 101st data point. So where is that data point? Well, let's see. We've got, 46 right here, and then roughly maybe 48 right here. Mostly they're just really close to 50, but below 50. So the 100 and the 101st are in this bin right here, most definitely. That's like, 24-ish? So we are most definitely in this bin between 7 and 10. So therefore, the only possibility for this histogram is that the median is 7. The median for high school A is 7 because this high school has 200 teachers, which means the median is between the 100 and 101st data point. This data point lies in the bin from the bin including values from 7 to 10. So the median must be 7. It cannot be 6. All right, again, we only know that because they told us one of them was 7 and one of them was 6. So with a similar argument, the median for high school B is 6, because now I'm just going to double check my answer and do the same reasoning for this high school. So this high school had a total of 221 teachers. That's an odd number. That's a little nice. So we're going to have 110 data points on that side, 110 data points on this side. And so the median is the 111th data point. It actually has a center. So where is the 111th data point? So here we have roughly 79 or 80 data points. Here we have about 34, which that gets us pretty darn close to 110, doesn't it? It gets us past 110. So we know, because we're past 110 already, the 111th data point is in here somewhere between 4 and 7, but not including the 7, right? The 7's in the next one, so it has to be 6. Because the median is the 111th data point, which lies in the bin with values between 4 and 7. I might even put in not including 7, of course. So the median must be 6. Kind of a run-on sentence there. Sorry about that, but hopefully that makes some sense. Sorry for hiding some of the words there. All right, next, letter B. An additional 18 teachers were not included with the data recorded from the 200 teachers at high school A. The mean teaching year of the 18 teachers is 2.5. What is the mean teaching year for all 218 teachers at high school A? All right, this is kind of just a funky way of looking at the mean. Then you got to do some sort of fancy algebra. So remember, for the mean, you add up all the data points. So what we want is we want to add up all 218, and then we want to divide that by 218. That's our goal. But we don't have those numbers, so we have to get them somehow. What the numbers we do have is we have the sum. Maybe I'll even just write it that way. We have the sum of all 200 teachers divided by 200. And we have the sum of these new 18 teachers divided by 18. But we need to turn that into the sum of 218. So we essentially have to figure out, hey, what's this sum? What is this sum? And that will allow us to add them together finally. So it's just some fancy algebra. This, they tell us, is equal to 2.5. Well, I don't know what this box actually is, so I'm going to solve for it. I'm going to multiply 18 to both sides. And that sum is 45. So the sum of all 18 teachers is equal to 45. I'm going to do the same thing for the 200 teachers, because we know that average, they told us that. Wasn't it 8.2? I forget now. Yeah, 8.2. There it is. 8.2. I'm going to multiply to find the sum of all 200 teachers. So 200 times 8.2 is 1640. All right. So now that I have those two sums, I can find the sum of all 218 teachers by simply adding them up. So the total mean will be 1640 plus 45 divided by 218. Kind of a fancy way to ask a means question, but there it is. 7.73, let's call it. There we have it. All right, and letter C. The standard deviation of the teaching year for 221 teachers at high school B is 7.2. If one teacher is selected at random from high school B, what is the probability that the teaching year for the selected teacher will be within one standard deviation of the mean of 8.2? Justify your answer. All right, now, again, big distractor here. It would be very tempting. Oh, what's the probability you're within one standard deviation? Let's look at the normal model. Let's do a normal CDF, or just do the empirical model and call it 68%. No. That only works if the distribution is normal. And this most definitely is not a normally distributed sample. All right, this is definitely heavily skewed to the right. So we simply just have to find the proportion here. How many teachers are within one standard deviation, and then divide that by 221. So within one standard deviation, what is our interval? So the interval of plus or minus 1 standard deviation. What is that? Well, the mean is 8.2 plus or minus 1 standard deviation. 1 standard deviation, this is essentially a confidence interval in some ways, but not quite. 1 times 7.2. So we're adding 7.2 and subtracting 7.2. So what does that give us? Well, I should do this in my head, but it's early for me. So 1 and 8.2 plus 7.2 is 14.4. So from 1 to 14.4. So how many teachers are within that interval? So that goes from here all the way to, did I type something in wrong? I did. That should be 7.2 plus 8.2. I was like, it has to be 15. It can't be 14. All right, 15.4. Good. 15.4 brings us up to the 16. Again, because we're only integers, there are no numbers between 15 and 16 in this data set because they're all integers. So I want all of these data points here divided by the total 221 will give me the total. So what do we have here? Maybe 79 is the first bar, and then call that 34. Call that one 28 maybe. Call this one 29. It's a little bit higher. And the last one here, call that one 19, I'd say. There we go. So we're going to add those up, divide by 221, and that will give us the total probability of randomly selecting a teacher within one standard deviation. I might as well do that. I don't know if you actually need to add them all up. I know in the calculus test you don't need to actually do arithmetic. 189 out of 221 is 86%. So 189 out of 221, which is 0.86, roughly. All right, so there's an 86% chance that you will pick a teacher within one standard deviation. Again, it's not normally distributed. That's why it doesn't follow the proportions of a normal distribution. All right, hopefully that made some sense. You've got to think about some stats concepts in a bit different way for many of those questions, didn't we?